Day 15, Umbraco with CQRS by Adrian Ochmann. CQRS, Command Query Responsibility Segregation, is one of my favourite architectural patterns, especially in the combination with DDD, Domain-Driven Design. Some time ago, we had an idea to create a sample project using Umbraco with CQRS. We created a sample Umbraco v9 application and focused on the members domain for the example purposes. Our goal was to apply the clean architecture concept onto it and implement the base for the future clean Umbraco CQRS projects. Today I want to share and explain these concepts and code with you all. 1. Clean architecture. Clean architecture is an architectural style concept that can be defined as a set of guidelines for systems that strictly follows the principle of separation of concerns. The main goal is to divide the application into specific, responsible, simple, extensible layers. The picture, the clean architecture diagram taken from Clean Coder blog, shows a layered architecture that puts the domain as an entrance to the design system. Each inner layer does not depend on the outer layer. This architectural style evolves or has similar concepts such as hexagonal architecture, ports and adapters, onion architecture. You can read more about it on Uncle Bob's article. For the application layer and solution itself, there are a few techniques to organise its structure. The most common are 1. In the first structure example, the application layer contains all of the business rules, infrastructure aspects, repositories, services, etc., and only domain entities and shared code is extracted to the separated projects. 2. In this example, structure has the core project that contains all of the above described and the domain entities, all bundled together. 3. Last but not least, we can have a separation of responsibilities to dedicated layers for domain entities, application rules, domain logic, infrastructural configuration, and so on. Note, sometimes the application layer is also called core. Note, sometimes the shared layer is also called shared kernel. 2. CQS and CQRS. CQS is a design principle that is based on applying the separation of concerns in our applications. In short, command query separation stands behind the idea every method should either be a command that performs an action or a query that returns data to the caller, but not both. CQRS is an architectural pattern and is usually applied at the top of the application layer. It's based on CQS principle. In short, Command Query Responsibility Segregation stands for separating commands as writes and queries as reads in regards to the storage within the application. You can read more information about CQRS and CQS by visiting the external resources listed in the reference section in the bottom of the article. Let's focus on more technical solutions of CQRS. 2.1. Command plus handler plus dispatcher. Commands are used to modify state. A good example is the command to register member. It contains all the needed details on processing this command by command handler. Below you can see the markup abstraction for a proper command model. Command doesn't return any value. Command handler is used to process dedicated command. As you can see, generic T command is there for letting know command dispatcher what exact implementation of command handler we need to get. It's mostly for DI to know about the dedicated implementation, and then to send a dedicated command object as strongly typed object further. Command dispatcher is an object that links the action request with the appropriate action handler. I can't describe it better, so let's see it in the implementation. Then we can extend it and implement, for example, the in-memory implementation of it. 2.2. Query plus query handler. Queries are used to read the state of a dedicated domain object. They are not changing the state of the systems. The markup abstraction for the dedicated query may look like this, where tQuery is a strongly typed definition of the query, e.g. get member by email, and tResult is any kind of the result type. It can be a DTO, list of DTOs, etc. Query handler is used to process the dedicated query. As you can see, tQuery is there to let know our query dispatcher what exact implementation of query handler we need to get. It's mostly for the DI to let know about dedicated implementation, and to send a dedicated query object as a strongly typed object with tResult return type. Query dispatcher, same as command handler, is used to get a proper query handler and dispatch it. It can be also a wrapper to wrap exceptions. That is a common use case of them. Below code example shows the in-memory implementation of the query dispatcher. 2.3. Aggregate Value Objects DTO POCO. What is it? In short, aggregate. A single and simple domain object with the identity and domain operations on it that aggregates it all together. Value object, similar to aggregate but without the identity. When we compare value objects only if all properties match each other, it means that those are the same objects. Each value needs to be the same, no need to have any identity to make them equal. DTO, data object without any logic in it. Aggregate value objects, DTO, POCO, are a very large topic and are for the explorers. If you'd want to explore more about them, check out some of the below materials that describes them in more details. 3. Example details. Let's begin with a diagram about our domain example for member registration and management. We design layers and its dependencies there. Like the onion architecture concept, the domain layer does not know anything about other layers. Application layer knows only about the domain and infrastructure, knows all about application and domain. Shared project is used for applications or shared implementation, can be used in modules with the same architecture. Let's focus on 2 examples for simplicity. Member registration, to explore how we can create commands. Getting member by email, to explore how we can query data. Let's start from the entry point of our application, startup.cs. We are registering the application and infrastructure layers to our DI. Those are extension methods that perform registration inside proper dependencies. Note, add queries, add commands, add command dispatcher, add query dispatcher. Those are extension methods that are using Scrutor to find implementation based on the abstraction on invoked assembly and automatically register it in the DI. 1. Member registration. In the app, we have a form that is calling the action controller to perform form submit. This surface controller looks like this. In it, we are mapping the request model to our register member command object and then perform the execution for this command. What we are doing in command handler is... Now, there are a few approaches to validate command data. Inside command handler, via attributes, not that clean, by fluent validation and the request model binding. It's a very clean way to do that, what I highly recommend following. In the code, we are throwing application layer exception if validation is not met. Clever. If all is okay, we are simply registering the member. 2. Getting member by email from the API controller. Let's now see how we can perform the query operation. For that, let's use a little bit different approach with Web API application. This is how our API controller looks like. The root for it is site/API/member/email. Here, instead the email placeholder, we'll put a valid email address that will be binded into getMemberByEmail query object visible below. After that, we are processing a query via the handler to get a proper query response model. Note, we could perform the mapping to DTO object, but for simplicity we are returning the Umbraco member definition. Voila! 4. Summary. I hope this example shows ideally how simple and effective, in terms of its scalability and maintainability, this architecture style can be. As every other, it has pros and cons, and is not always a good choice to introduce it. For example, when we only need to display content, it could be over-engineering and overkill. By applying CQS, CQRS, and clean architecture concept, our code gained more readability, layer responsibility, and standardized style. It can be seen as more complex to initially understand and introduce to the first project, as setting it up imposes an effort on creating abstractions, commands, queries, and keeping the domain clear. But from the other perspective, especially for the complex solutions and large teams, it can speed up the delivery process drastically due to its need for standardization and universal patterns within it. Specific boost is possible to be captured with a combination with event storming sessions, whereafter the domain explorations and transforming it from the events cards and clients' needs into software is possible on a very early stage, even during the workshop, and using a human language for it. Implementation then really becomes details in the end. If you have any thoughts, doubts, concerns, or maybe some experience with any of the above described patterns, reach out to me on Twitter and let me know what you think about it, how you are using it, etc. Cheers, happy coding.